Good morning, my outstanding friends. We're going to have some fun today. We're going to be looking into this baffled by the balls in the walls. Let's find out why they are baffled by the balls. Okay, my Mudfossil friends, what are we talking about? A wall growing eggs. Well, let's see what they have to say here.
Researchers have been baffled by a mysterious mountain in the Golly village in Guizhou province, southeast China, that produces strange rock spheres called stone eggs. According to the locals, the mountain regularly produces large, round rocks as heavy as 660 pounds and drops the stone eggs once every 30 years. Local residents collect the spheres and worship them, praying for good luck.
All right, let's discuss what they have found. Okay, so here's what they have found, and they have no explanation. Here's what it has to say.
Scientists have not yet provided an official explanation for this unusual phenomenon.
Well, I have. Let's take a look at my explanation. Okay, let's just start with Sam Oswegowicz over in Bosnia. This is the first huge round ball that I saw was from Sam. Oh, it's got to be 10, 12 years ago now. And he is looking into these spheres as being created by some advanced culture. And I say, no, these are biological. And that is the imprint right there of the stalk that attached to that ball when it was alive in the body of a creature. This, my friends, is what you just saw Sam Oswegowicz standing next to, was this stalk removed, and it takes the scale with it off of the sphere. This is a tendon enthesis. Okay, what we're going to be looking at is tendons and their enthesis. And this is what it says here. One of man's greatest attributes is his ability to move. Purposeful active movement is dependent on many factors, and we'll go over those factors, how you can become flexible. Primarily on the ability of a myocyte to contract and thereby reduce its length. This motion is transmitted to the skeleton through a collection of longitudinal oriented collagen fibers, which is a tendon. When I show you what a tendon consists of, it's going to blow your mind. Even if you're a doctor, it will probably blow your mind. Okay, my friends, this is going to rock your boat. You have muscles, and they make you move around like that, but every muscle has a tendon, which is just a barely flexible thing, and that tendon has to anchor, and it makes a ball inside of bones and so forth. Let's see if we can find what actually happens inside the bone. All right, there's actually two different types of enthesis. There's what they call a ponerosis tendon, which is a flat, thin sheet, which is on your abdomen and your back and so forth. And then there's rope tendons. We're going to be looking at the rope ones now. These are the ponerosis style, and they just sort of lay into the tissue and hold on as these sheets move back and forth on your stomach. This is the kind that are in the bones. This is how they end up, but all of these tiny little fibers come down, and they all have balls on the end of them. And let me show you what they look like. All right, let me try to explain to you what happens with a tendon. And this is the rope style tendon, and this is the Achilles heel. All of these tiny little fibrils come down, and there's a whole ton of them, and then they lock into this ball down here. Then all of those fibers come up and they attach to muscles. Well, they're pulling those muscles all the time. They're under extreme tension. So they have to be locked in and they have to be anchored. But the key I want you to see here is how many of these things there are and how tiny they are. All right, so here's that fiber come out. It's a big tendon. It's the big rope tendon that comes up from, well, actually this is just a little piece of it. Well, actually, I guess this is the whole one they're pointing to, but there is 1 million fibers in here. And I believe that they're not showing the entire tendon. This is just one of the fibers. In that fiber, though, and this is only 100,000 angstrom units, which is almost nothing. Angstrom unit they use in electronic orbitals. And then they come down to here, and there's a bazillion of these, and they're 20,000 angstrom units. And then there's a bazillion of them in that, and each one of those is 2,000 angstrom units. And then it comes down to 200 angstrom units. You see how many fibers there is in this thing? And then all of these tiny little fibrils come out, and then they unwrap from these polypeptide chains. Polypeptides are amino acid sequences. And this is 14 angstrom units across here, I believe. 14 angstrom units is molecular atomic unit scale. Angstrom units, I think I showed you, or I will show you how big they are. Okay, like I said, if this doesn't blow your mind, nothing will. This is an angstrom unit. An angstrom unit is literally the smallest unit of measurement there is. And that's the sign of it there with a little A with a circle over the top. It is a unit of length equal to 100 millionth of a centimeter. It's 10 to the minus 10 meters, used mainly to express wavelengths of atomic and intermolecular interatomic distances, which is the distance of electrons in a nucleus. That's what we're working with, is angstrom units. Let me show you this. Okay, just remember this. There's two styles of tendons. There's the rope style, and then there's the aponeurosis, which is the flat. Let's take a look at both of them. But they all have these anchor balls in them so that they lock into either flesh or they lock into bone, or actually into muscle and bone, both sides. Okay, I told you there's two different styles of tendon. This is the aponeurosis style, and you see how they lay out in layers like this of the balls on a flat sheet. These are the ones that embed in the bone and the muscle on both ends, so that your muscle can pull against a tendon on each side. And that gives it a little bit of give, and then the muscle can really make it contract. But that gives it just a taste of a give on each end. But they have to be anchored, otherwise they rip right out. And those are those tiny little balls. Okay, you see this right here? This is the type of ball that Sam Oswagowicz was standing next to. It's a ball here, and they break the stem right off, and the balls are left laying around. This is an injury. It was supposed to be anchored into here. I'm going to show you one that is still anchored and still has the actual stalk. Most of the time they break right off here because of the pinch going through there, and the scale comes off with it. But occasionally you'll get the full one will stay intact, and I'll show you one right now. All right, there's Sam, and don't forget, I say that's the scale that comes off with the stalk. And you say, no, that couldn't possibly be. Look at the size of that thing. In us, they're very, very microscopic. And this is also, when I just showed you, and I say it snaps right off here, and the snap spot is right here. And it just comes with it. All right, so is there a big one around? Yeah, well, there is. There's one right there. That's Arches National Park. All right, in Utah. I believe it's in Utah. And this is the strap coming down, and that is the ball. You see the size of that thing? Now, it embedded into tissue that was right up to here, and that is what locked this ball in so that the tendon could go this way. It's all eroded away. Everything's basically gone. You just left that strap. I don't know why. This one here, because they're side by side, there's one right here. You see it? That one also came down. They all have a little core in the center. That one came down, probably right to this one here. This ball here. But they were all over the place. You see them over here? There's balls over here. They're everywhere. And because that was a big flat sheet of tendinous ponerosis tendon. That's what it was. The creatures were absolutely astronomically large, and I can't account for that other than that they are here and they were written about. All right, now if you're new to this has to be blowing your mind, and I understand that. This is a membrane, and in us, if you held that up, you could look right through it. It would just be almost like it was just a piece of cellophane, and you'd look right through it. Now, in some of the creatures, this is what they call bilipid, two top and a bottom, two layers. and there's fatty stuff in the middle, and these are phospholipids. This, in where I'm going to show you right now, it's 6 feet or more between the bottom and the top layer. And this is it right here. These are the tendons in a creature that is a friend of mine, Tyson Carlson, out at Tyson's Mudfossil Adventures, has this membrane. He's been researching this area. And here's, I got another spot over here. It is right here. Look at this. That's the bottom layer. That's the top layer right there. You see this? You see these whenever you see these little things around the edge of them like this, you see those little edges? That means these were attached at one time, glued together. As they dried out and they sort of separated, there used to be some slippery stuff in there so they could jiggle around and they didn't come apart. Now they have come apart. And these are what they call ion channels, protein channels to go in and out to service the membrane. And then that fatty stuff was right in the middle. This is at least 6 feet thick. And that's just a membrane. In us, you could see right through that. So he's got tendon balls out there that are this big, bigger than that probably. But Sam's is absolutely enormous. And some of them are even bigger than Sam's. I mean, look at the size of that thing. And that, in us, again, absolutely microscopic. Okay, so they are baffled. They're baffled. How did this happen? These things are rode out of there. These people they don't understand, obviously, what's going on. They're worshiping these as eggs, and they are tendon balls. But what they are, I'm sure they're coming out of a gigantic creature, and I think I know what kind of creature it was. I'm not going to say because I can't see it. But you see, this is all bloody, meaty tissue that was here, and those balls are what anchors in there. It's a matrix of balls that can shift and pull and all this, but they always come back to where they were anchored. All right, so don't forget, all these balls are laying all over the place. Now, how did these balls come out of these walls? Well, the walls are being eroded, just like in Huntington Beach or Huntington Cliffs. I forget what I'm always wrong about what I say about that place. I can't remember. Hold on. All right, so how did all these balls erode from these walls? Well, in that place, it's in a wall, sort of a muddy wall, but sometimes they're right up against the ocean. And then the waves come in like this, and all of that stuff erodes down, and the skin at the top collapses, and the balls fall down, and everything else turns into mud. And I can show you that absolutely happening right here. All right, that's in Huntington in United Kingdom, and that is right there is the skin of some creature, some kind of skin. And underneath there is all of the fleshy stuff like I showed you a second ago. And all of that matrix has these balls. And those balls are falling out of the wall right now. And then the white stuff is falling over the top of them. And all of the clay and the flesh are turning into this mud. That's what happens. The flesh turns into mud. And these are the balls. And here's these are called the Moki marbles. These are out in Utah and Arizona. They're all over the place because the creatures were all over the place. There is no place that doesn't have these. Nobody's ever been able to explain them, so they've just called it a mystery and, and just walked away. I can't walk away from things. I just can't do it. This is biology, no question whatsoever now. So anybody that's hiding from this is just hiding from reality. You see all these there's all kinds of little creature-y things growing on these balls because these balls are saturated with blood. They just came out of a bloody wall. Now let me show you what happens in this is in the ocean, and they have some salty waters, and whatever this grows is adaptable to salty waters. On the freshwater side, if these balls eroded out, they wouldn't grow this stuff. They would grow green moss, and I can show you that. Moss loves blood. Moss loves blood. I have things in here that have been sitting here 10 years with moss growing in them. I know I don't water them or anything. The moss is still growing in the arteries. I got to be honest with you, this one blew me away when I saw it. You see these little things? They look like little green mice. Look at them. Every one of these is one of those little tendon balls, a tendinenthesis, whatever you want to call them. And they're all over here. Look, way up here, all everywhere. They're everywhere. These creatures were just staggeringly large. Now, this is, scientists can't explain any of this. They have no clue what this is all about. This is fresh water, so they grow the moss. In the salt waters, they grow some kind of sea stuff. Okay, so I'm telling you, the size of the creatures were unbelievable, and this has nothing to do with millions of years in one picture with a layer after layer after layer. This is a tendon. This is what we're talking about, tendons. That is the main anchor of the tendon, right there, that ball. And all of these little fibers are connective tissue. And what that means is this can move this way and that way, because these things can slide on each other. They have little slurpees, small leucine-rich proteins, the gooey stuff. And you have to keep them moving, otherwise you stiffen up. Now, so this thing can do this, but over here there would have been a bone, and over here there would have been muscle. And I have one of these exactly identical to that in my shop here, and I'll show you the pictures of it in a second. But that's the only reason it's sticking right up here, because tendons are tough as hell. They're one of the tough. They have the same strength as steel. All right, here it is right here. In essence, tendons are smooth, cord-like, flat or round structures. The flat is the ponderosis, the round is the rope-like. Composed of parallel fibers, they're right next to each other, flexible enough to be turned around and moved around and around bone surfaces and all kinds of stuff, deflected beneath reticula, yet they have incredible strength, and I mean incredible. More per unit area than muscles. They're much stronger than muscles. And that's why the muscle eroded from that thing I just showed you. In fact, their tensile strength is as great as that of bone. It's as strong as bone. Bones eroded in the salt water. That's why we didn't see a bone. We only see the tendon. We don't see the muscle. So the tensile strength of these tendons is just as strong as bones, with a breaking point similar to that of steel. Large flattened tendon structures are known as aponeurosis, which I mentioned there. So back to the one I'm claiming is a tendon. Here was the muscle of the bone. Bones didn't do well in the hot salt water flood that this was, and muscles just erode because they're just erodible. And that's what turned into mud. All the muscles basically turned into mud. There are places where they preserved fine, but where they were long into the salty waters, they turn into mud. Now, hold on one second. All right, I told you I have one here. Here it is right here. This right here, from here over to here, is the tendon that's sticking up in the ocean. This forward here is muscle. This shot shows, back here was the bone. Well, this one shows it with the bone. Same muscle. This right here to here is the tendon. See that circle right there? That locks this right into the bone. The two of them work together so that this thing can move this way and that way, but still it's locked to the bone right here. And then the muscle goes from here out. And then the muscle erodes fairly quickly. Here it's quite heavily mineralized, but then it hits a point where it's just almost all what they call sarcomeres, and it just falls apart. This is all the blood that services this muscle. And I can show you something. It's called a crab. And I will show you that, and that will also blow your mind. So what did we see in the ocean? We saw this right here. From that ball right there over to here. Muscle's gone, bone is gone. Let's look at it one more time. And remember all these little fibers. You see that? See that ball right there? That is the same ball I'm going to show you right now on this one. There's that ball. All right, all the rest are tendon fibers. You see them all here? They're tough as hell. Tough. And they don't require hardly any red blood. They are. That's why you see mostly white and connective tissue, brownish looking stuff. Same thing on mine. You don't see any red in there. You see it? It's just all brown. Because it doesn't require the red. The muscle requires the red. And that's where it comes from, up here, the blood. If you don't have red in your muscle, you're not going to have enough oxygen to make it work. It's just a rubber band. It requires virtually no nutrition. Once it's established, she's about ready to go. All right, here's some eroded tendon. And I don't know where it is in here. It could be anywhere. But you can see the bundles in here. So it's one of these somewhere in here. And then coming out of that, each one of these bundles, you got all these tiny little fibers. The same thing you see, boom, boom, boom. And then at the end of the fibrils, you got those little tiny balls. And they're in the angstrom unit size. It's absolutely incredible how intricate these tendons are and how tough they are, how much abuse they can take. You take a guy in a football, playing football or boxer or any of that kind of stuff, it's incredible tension on their body, ripping at everything, and these things are the things that make it so that you don't get torn to shreds. All right, what you have to understand is there's a ton of different styles of tendon balls. There's these that are just solid like looking things. Then you get some like this that have a coating around the outside of like the Moki marbles, and then there's a reddish something that this gets. Okay, I think I've shown you pretty much enough to cover the topic, basically. But what you have to understand is there's a lot of different styles of these tendon balls. There's ones that have like a fabric inside, and I think they might be able to do a little bit of this and that and still stay. And that's right there was where it would have attached into it. And then there's other styles that are like the Moki marbles. They're just hard little solid things, but they do have a little tiny strap on them. And here's what they look like when they're all strapped up and in a creature's body. This is it right here. All right, those balls run to straps. All right, the straps are usually all wrinkled up in a ball. It's just stuck together and it's not pulled apart. This is skin, and it's pulled apart here, and you can see the stretched straps. All right, and some of them have eroded away and left the balls. These are the same exact balls as the Moki marbles, but they are not the Moki marbles. This is called the Mars Morse code. This is on Mars, and it is on Mars, and I can tell that for a fact because there is 100% no erosion here. There's no water erosion. This is sandblasted. It has never been. Once it got sandblasted, there's no water has touched this. This is the only place that it can happen is on Mars. Now, not only that, this was from the Mars Curiosity mission. This right here is the Mars crab. All right, look at this carefully. That right there, my friends. As I've told you, I'm very, very into biology. I will speak to any anatomist, doctor, physician, I don't care who they are. I know as much about this as anybody that's breathing oxygen. That is an artery. That is the vein. The vein brings the blood back. The artery pumps the blood down. These arms are the blood vessels that pump the blood into the sarcomeres. And Roger, what are sarcomeres? Well, those are sarcomeres. And how would I know that? Well, here's why I know it. You see them all blocked up like this? Broken down here, and a little slip in the center. These are supposed to pinch. This is all connective tissue. All the red stuff that has run off, all of this dusty stuff is nothing more than bloody wet tissue that was normally would be used to be contracting these sarcomeres. And I will show you, this is right here is the Mars crab. It's right down here. That pumps the blood into all of these. If you didn't have that, you would not be able to, your muscles just wouldn't work. And when you start to really run and jump and all that, you start pumping, and that just plump, keeps pumping blood into your muscles. The more you exercise, the more your heart beats, the more blood goes in there, because you need oxygen, you need nutrition, you need all that stuff, or you cramp up or you die. One or the other. Now this picture's from NASA. All these are from NASA, from the Curiosity mission. I contacted them about all this, and I can't believe they're that incompetent that there's nobody that they can contact that's a biologist or an anatomist. And I have contacted them. They say, yes, Roger, you're right. Don't use my name. This is another picture from NASA. These are the Mars blueberries. Identical to the Moki marbles. Identical. No difference whatsoever. Zero difference. There they are right there. No difference whatsoever. There's a basement layer where all the gooey stuff at the top has eroded and turned into mud from running off on Earth. Up on Mars, it just dusted it off, so it left all those fibers. Here, it's run off and turned into mud. Up there, we can see the fibers still, and these are the fibers right here. This is the fibers that we're going to see attached to these balls and the straps. All right, the straps are pretty tough. The balls are tougher than hell. And all this gooey stuff is all been eroded away. And here it is up on Mars. Remember that pattern. Remember the balls, and remember how they stretch. And this, if you look it up from the Curiosity mission, that's exactly what it's from. And this goes back to 2012, I think. I think I told them about this 2013, 2014 NASA. I said, this is all biology. You guys are just wasting your time looking for, we're going to try to find microbes and all this stuff. Well, NASA went to Yale University and had them do a study to see if this was possible to have this kind of preservation, and they said yes. But they distorted the whole thing, so NASA got a distorted information about this, so they just let it go. Or I don't know. Maybe they know everything about this, and they're just trying to protect us from what reality is, and keeping everybody perfectly happy, deluded. All right, because this is kind of scary. There's no question about it. It's scary. But if you're a PhD, perfectly happy, deluded, that's fine. You can live with this. I want the truth. I don't care how scary it is. I want the truth, and now I have it. I figured it out. And to have humanity almost universally reject truth sticking right in their face is very, very difficult for me to accept. And I can tell you what, there is a God, and God will not accept that. If you can't accept truth, you're just not going to be welcome. Because everybody dies. What happens after you die, I have no clue. But I'm telling you right now, I'm starting to see everything that was written about these giants, these creatures, these dragons, all of that stuff. And I go to Apollodorus. I don't necessarily go to Bible. The Bible has a lot of passages that seem to be quite valid. But Apollodorus and Ovid and Hesiod, that's where I go. And that's myth. And they talk about Earth giving birth to creatures. And I believe that. I believe that's absolutely true. And I believe that Jupiter gave birth to Venus, and Venus was the one that wreaked havoc on the Earth and caused the flood that killed all these creatures, these gigantic creatures all over the Earth. They were gigantic. They had to be wiped out. Venus was dispatched from the god Jupiter, who was Zeus, to come and destroy all these creatures, and then it went and hit Mars. And here's what it did to Mars, and it wiped Mars right off the face of everything. It's wreaked havoc. That's wider than the United States. And that happened when Venus collided with Mars. And this was not that long ago, my friends. Everything I have in my collection, and I have virtually everything, is from this flood period. And here's another one. Look at the size of this. There's a person standing there. This is some kind of ribs. A lot of meat on those babies too. It is what it is. And if you can't accept it, I don't know. If you can't accept truth, then you're in trouble. Oh, by the way, did I show you the sarcomeres? Here's the sarcomeres. These are the ones that I just showed you with the Mars crab. All right? All of the red stuff is eroded out of it. Up in Mars, it's just sort of dusted out. and was blown off by the dust and stuff that goes up there, but there was no water. And that's why I can tell it's Mars. Now, these are pinched together sarcomeres, and these are open up ones. Petra they got the same stuff. Petra is made out of sarcomeres and muscle and an artery. I've shown this over and over and over. People just can't handle it. Same thing with Stonehenge. Look at this. This is a foot at Stonehenge. It's called a heel stone. It's a foot. There's no question about it. If you know anything about biology, at the tips of your fingers and toes, you have a terminus of the artery and the vein. There it is right there. These are the artery and veins at the tip of the toes. And this is where the blood supply come in. This is where the vein is here. And that's a foot. I mean, obviously. This is where it was laying sideways. They all died in the Great Flood. As a, they had to be destroyed. And there was a second one on here. It was called a twin stone. And that's gone. Somebody took it, I don't know. But now it's only got 1 foot. And Stonehenge is completely made out of body parts of giants. All right, I told you there's a batch of different types of tendon balls. Well, here's the ones that have the crystals inside, and that is inside of a tendon ball. These people are crawling around on these crystals that have turned into crystals. And this is the type of tendon ball that they wear. Where is it? It's around here. There it is right there. That's what they're crawling in. Okay, my friends, I think I have made my point pretty well, but this is an Achilles tendon, and this is all those little fibrils, and they end up going to the muscle, and there's a bazillion of those tiny, 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 tiny little things at the end come up and attach to the muscle, and these are these tiny little things. 14 angstrom units is I mean, it's just unbelievably small. Now, and then they get unbelievably big, because I'm going to tell you what, this right here is, somebody was here back then. This is in Fuerte de Sempiata, Bolivia. And they were using some kind of machinery to cut these tendon slabs. This is a tendon. And they were cutting them and making those walls. I have a lot to present about that. And I think other than that, I will leave it for today. But you have seen all kinds of things here. I hope you understand what you have seen and can allow it to sink in a little bit and think about it. And we are completely living on just biology, and biology in space too. This, like I said, these are on Mars. These are the Mars blueberries. No difference whatsoever to the ones that are in Utah and Arizona. And don't tell me this is not Mars. This is 100% certain. There is no erosion here whatsoever. It's impossible to have that happen on Earth. The same thing with the crab. The crab could not happen on Earth. It's just impossible. The dust here is just undisturbed. It's just dust. It's just dust. And it has eroded out because of the dryness of the conditions. This doesn't happen on Earth. It just doesn't happen this way. So I have people all the time, they're just NASA, they're all lies. Well, I can tell you one thing. If they don't understand what they're seeing, it's just a total incompetence. If they understand what they're seeing and they just don't want us to know, well, then they're, as far as I'm concerned, frauds. So it's either they're incompetent or they're frauds, one or the other. But this is on Mars, my friends. Okay, NASA funded Yale to look into this, and as far as I can see, nothing ever happened, nobody got anywhere, and whatever. But we're paying billions of dollars for this kind of stuff, and as far as I'm concerned, they're not doing the job. Let's just put it that way, one way or the other. Why? I'm not certain, but it's not being done correctly, I can tell you that. If you can dispute anything that I have presented factually, I would very, very love to be engaged in that discussion on a Zoom meeting. I'll show, you can say why I'm wrong, and I'll say why I think I'm right, and we can do some research. But this needs to be shown to people so that we understand our past. That's all I'm asking for. All right, I love you all. Thanks, bye. All right, this is from Yale, and this is the first author from this study that they did. They want to know if this Ediacara organisms were some sort of failed evolutionary experiment. They claimed that these were all existed before any of the fossils they know about. These are the earliest, which are the mud fossils. And here's what they said about them in their paper. They called it exceptional preservation of soft-bodied creatures promoted by silica-rich oceans. They just threw in a name here to make it sound like they did something special. And it's found everywhere around the world in this one layer, which they call was in the ocean layer, but this 100% of the world was covered with ocean at this time, and they say it's a worldwide layer. It's a thin layer, and it's where all of these creatures were preserved. Exactly what I say. So it's time to take this and talk to the Secretary of Education about having us understand what our reality was. I presented all my stuff. I have DNA, I have CAT scans, I have specimens, I have chemistry, I have anatomy, I have everything done. And it's being refused by these same people. I presented my evidence to Yale, to Derek Briggs years before they took credit for it with this paper. So we're just going to continue on, and until the Secretary of Education, Miguel Cardona, responds, which he has not, and I've several times, and I just did it again last week. And education's fine. Good education for everybody. What is education? Right now, it's indoctrination of things that just aren't true. That's my last word for today. I love you all.